Section 6.5 is about the quadratic formula and the discriminant. The quadratic formula is a way that you can find the solutions of a quadratic equation, and it's this formula right here. It's based on the a, the b, and the c in the quadratic equation. All you have to do is plug the values in and you'll find the solutions. So here we're going to use the quadratic formula. First we want to figure out that the a is 1. It's the number in front of the x squared term. The b is 22. That's the number in front of the linear term. And the c is 121. That's the constant. We're going to take these three numbers and plug them into the quadratic formula. So we have opposite of b plus or minus b squared minus 4 times a times c all over 2a. One thing I want to point out is that this division bar is underneath the entire top. It's underneath everything. Some people mistakenly just put it right here and divide the second half, but that's not true. You divide everything by the 2a. Now we'll simplify. So 22 squared is 484, and so is 4 times 121. Minus here, so those are going to simplify to be a 0. So really you're just going to have negative 22 over 2, which is a solution of negative 11. Here's an example where we only have one solution for our quadratic equation. Here's another example. My a is 2, b is 4, and the c is negative 5. Plug those into the quadratic formula. Here we have opposite of b plus or minus b squared minus 4ac all over 2a. Simplifying, we get 16 plus 40 because we have a negative 4 and a negative 5, and times 2, that'll give me a positive 40. So we have negative 4 plus or minus the square root of 56 all over 4. Now the square root of 56 is not a whole number, so we can plug this into our calculator and get two decimal solutions. First we'll do negative 4 minus root 56 over 4 is negative 2.9. Again, that's an estimated solution, it's rounding. And the negative 4 plus square root of 56 over 4 is 0.9. So this quadratic equation has two solutions. For this one, I'd like to add 13 to both sides so that I can get this equal to 0. Now I can see my a is 1, my b is negative 4, and my c is positive 13. So here we have the opposite of negative 4, which is going to give me 4. Then we have negative 4 squared, which is 16. And then we have a minus 52. 4 times 13 is 52. And that's all over 2. So 4 plus or minus the square root of negative 36 over 2. We see that the square root has a negative in the radicand. Therefore, this solution is going to be a complex number. I'm going to have to pull an I out. So let's do that. We know square root of negative 1 is what I is. So then we can make this square root of positive 36 over 2. Continuing to simplify, we know this is 4 plus or minus 6i, because you know that the square root of 36 is just 6. And now I see that 2 goes into both 4 and 6, so I can rewrite this as 4 over 2 plus or minus 6i over 2. And then finish it off simplifying to 2 plus or minus 3i. Now here we have the quadratic formula, and the part in red here, the part underneath the radical, has a special name. It's called the discriminant. And the discriminant can tell us how many roots or how many solutions we're going to have in the future if we were to solve a quadratic equation. And this table summarizes that. If your discriminant is positive, you're going to have two solutions. If the discriminant is a perfect square, your two solutions will be rational numbers. If your discriminant is not a perfect square, your two solutions will be irrational numbers. But either way, as long as the discriminant is greater than 0, as long as it's positive, you're going to have two solutions. Well, if the discriminant equals 0, if it exactly equals 0, then you're only going to have one solution, and that's going to be an example of a parabola that only touches the x-axis in one spot. And then finally, if your discriminant is negative, we used to say that it had no solution, but now we say that it has two solutions, but they're complex roots. They're imaginary numbers. So let's find the value of these discriminants and then see what that tells us about the kinds of roots that we're going to have. Here my a is 9, my b is negative 12, and my c is 4. Well, the discriminant is b squared minus 4ac, so I'm going to plug into that. Negative 12 squared is 144. 4 times 9 times 4 is 144. So you get a discriminant of 0. If the discriminant is 0, we say that there is one rational root or one rational solution. Over here I'm going to rewrite this so it's in the proper order. 15x squared minus 7x minus 4. Don't get confused. You want to have descending order so that you can find your a, b, and c. So again, use the discriminant of b squared minus 4ac. Negative 7 squared is 49. 4 times 15 times 4 is 240. And we have two negatives, so this will be a plus. So 289 is what the value of my discriminant is. Now 289 is positive, so I know I'm going to have two roots. But 289 is also a perfect square, so that means I'm going to have two rational roots. If 289 was not a perfect square, then we would have said two irrational roots. So now that we've learned all the different ways to solve quadratic equation, here's a summary table of when to use each method and why. Graphing is not something you'll want to use all the time. It's not very exact. It's a good way to check the reasonableness of solutions, but typically algebra is a better method. All these other methods are using algebra. Now factoring you'll want to use sometimes if the constant term is 0, if the factors are easy to find, you'll want to use factoring. The square root property is good when you have a perfect square trinomial that can be factored is always helpful. Now completing the square can always be done. It's best when the b is even, because then you don't have to deal with fractions. So if the b isn't even this one might be a little more complicated. And then finally, the quadratic formula can always be done. It's something that has to be memorized. It might be a little tedious, but it will always work.